Hi folks, welcome to my Bit Retro Journal. If you saw my video at the end of April of this year, I sort of looked at one of the application suite that came with the QL, which was the Excel-like spreadsheet program called Abacus. And I wanted to continue that today and actually dive deeper and also look at Easel, which is the graphics program, and combine those two really give you a very Excel-like experience. And as I was playing with this, and you can see I've got a bunch of Abacus files, and that's actually an Easel file, and these are export files. It turns out that, what I came away with is that if you look at some of our favorite 80s 16-bit next generation computers, and let's leave the IBM PC out of it because they sort of dominated the business arena. But the other ones, the Mac Classic, the Amiga, the Atari, and then the QL, which wasn't as big a part of the 16-bit revolution, they each sort of ended up having their sort of place in the computing world. If you look at the Macintosh, when it came out, it was designed to be for writers. It was for desktop publishing. They had built-in, bundled with it was Mac Write and Mac Paint so people could write and express themselves. If you look at the Amiga and the Atari, it wasn't clear initially what they were going to be. In fact, I was looking at researching them a bit, and I don't think, at least for the Amiga, I don't think anything came bundled with it. They had some software that was part of Amiga Workbench, like Amiga Basic and some demo stuff, but they didn't really have any applications that you could really do immediate work with. And the Atari, I'm not so sure, but probably the same. And I think the reason why is because there's probably sort of this idea that, well, these are powerful graphics computers, and perhaps, people will use them for gaming, and you weren't going to bundle any old game with them because you didn't really know what users were going to play. Eventually, I think the Amiga 500, when it came out, they started bundling it with some games. I think Batman or Spider-Man was one of the bundles. But initially, those machines came with very little. And so you really had to buy software and wait for that software to be developed in order to use it. And of course, they had very powerful software for both the Amiga and the Atari, and especially in the graphics. But eventually, I think the Amiga sort of settled into a computer for artists. In fact, when it was first announced, they had, was it Andy Warhol, right? Was sort of one of the folks at the grand announcement. And I think the Atari, because it had MIDI support, musicians sort of used it. Not that those were the sole users of it, but again, if I were to categorize it, Macintosh 128 Classic for writers, Amiga for artists, and maybe the Atari for musicians. Although, again, there are lots of regular users on those, so don't flame me on my channel. But what about the QL? Well, it was designed to be a business machine, right? That's what Clive Sinclair wanted, and that's why it came bundled already, with this 128K computer, with a suite of, Microsoft Office-like applications, a word processor, a spreadsheet, business graphics, and a database. And I'm not going to talk about the database. I've already talked about the word processor, and I've already talked a little bit about the spreadsheet. Today, I want to focus more on the spreadsheet and graphics because that's very Excel-like. But what it's useful for, more than business, which the QL failed at, is for research. And you can do some really cool out-of-the-box scientific, yeah, why not? That's a big word. Data analysis. And I wanted to show that to you today. And specifically, when I was in school, I took a simulation course, actually 2 semesters worth it. And, we learned about random number generators and how they were created using mathematical formula. And now that I'm many, many years later teaching to students, I actually am doing the same thing, except now I'm not doing it in a simulation class, I'm doing it in a security class. So random number generators are actually an important area in computing. And in fact, I have this document. It's from the University of Utah, not my university. I mean, I didn't go there or anything, but I just found this off the internet. And it talks about the a random number generator, which is actually the Park-Miller random number generator. And it sort of is based off of this formula, x equals P1 times x plus P2. The n plus 1 just means the next x equals the current x times P1 plus P2 mod n, where P1, P2, and n can take various values. It turns out the specific Park-Miller one is one where if the n is 16,807, which is 7q to the fifth, I should say, P2 is 0, and n is 2 to the 31 minus 1, that this ends up being a pretty decent pseudo-random number generator. And what they do is they use scatter plots. And unfortunately, this is black and white. I can show you maybe a picture of what this looks like in color. And what they've done is they've done a scatter plot of 100,000 dots 3 times in 3 different colors. And what the reason they do these scatter plots is to show that this has a nice random distribution. Here's one where they've only done 1,000 dots. And then up here, they've done one where they use different values. So they used values of 263 for P1, 71 for P2, and then n is 100. And when you do that, you generally get, there's not 100 dots on here, and what you're getting is clumps. And so that shows that you can do an analysis to say, okay, this is not evenly distributed. This is creating clumps. And what I want to do today to demonstrate that out of the box, we can do this sort of data analysis on the QL. And so I'm going to sort of dive a little deeper into both, this x equals P1 times x plus P2 mod n, using both the bad values to demonstrate a not good pseudo-random generator, and then using, again, the magic numbers of this 16,807 is 7 to the fifth, and this is 2 to the 31 minus 1. And I'll plot those out just to show you. And this is something I do in my simulation class, and this is what I make students not do in security class, because you use pseudo-random number generators in security, although this is considered a linear congruent random number generator. And linear is not a good thing in security, but it can still be useful, and certainly as in programming especially. And so that's what I want to do today, just to demonstrate the power out of the box on 128 QL. Or some of the things you can do. So let me set up the computer, and then I'll show you how I can go about doing some manipulation in the spreadsheet to create the random sequences, and then in the graphics program to plot them. All right, let's do that. All right, so I'm in the spreadsheet program Abacus. Before I start doing some of the more analysis stuff, I just wanted to also show you that I created this form, and I kind of got this example off of an Excel tutorial video from last year, or maybe it was 2 years ago, and how to create a form. So this form, actually, most of this stuff is text, but it has some, so these are functions: ask for a number, ask for an item, so that's text. It asks for a number, asks for text. You can see this on the bottom here. As for price and quantity, and then it'll actually compute that, and then also compute a running total, and the n is sort of a flag that sits there so you can clear things. So think of a little cash register, and then this also has a bunch of if conditionals where it'll tally it. And there's even a fun little right here where it'll print the pound symbol for number of quantities. So if, again, the way you run this is you go F3 execute, and it says order number. So it's order number 1, item number, let's say there's shoes, price, let's say $24.95. Maybe I get 2 pairs. And you can see it updates it, and so now let's say I get a pair of socks. So again, I'll do F3 X. You can see this could be like a little cash register program. Item number 2. And this time I'm going to get socks. Price, maybe it's 99 cents. And I'm going to get maybe 12. And you can see that it tallies it, and it has a little tally on the side. If I want to clear it, I can just go put a Y on here. So you go, and now if I go F3 execute, I can just 0, 0, 0, and it'll just zero it out, and then I can put the N back in. Well, if you leave the Y, then it won't be any tallying. It literally just does a single order each time, and the N basically tallies it up. So yeah, so that's kind of a cool little spreadsheet thingy you can do. But that's not what I wanted to talk about today. By the way, I'm going to use my microdrive just to show you this can be done with a microdrive. So let me show you a little formula I created. So I'm going to zap this. And I'm going to load F3 load NDV1 linear congruent generator rand. Let's see if this microdrive won't embarrass me while I'm doing this demo. Yep, loading it in. And here it is. So I've created a small little spreadsheet. I have constants on the right-hand side here. And then you can see this is an ask n seed. And then here I've got a formula. This is a pretty long formula. If I go F3 amend, you can see what it actually says. So it basically, so I couldn't figure out how to do modulus, so I have to do the long way about. So the A1 times index 7.1 plus index 7.2. That's the P1 and the P2. That's if you use the cells G1 and G2. The problem is when I copy these, it'll also change the G1s and G2s. There's no way to keep that cell constant other than using the index value, and then the minus int. So I'm doing the since I couldn't figure out modulus, I'm doing the multiply. Divide, take the int and multiply by n. Like I said, I posted the formula on how to do mod with int. So that works. And so here's what I'm going to do. So this is the bad one. So let's get out of this. And so what I want to do, and right now the way this is the way they do scatter plots is if you have x1, x2, x3, x4, x5, x6. They sort of explain it in this. I don't know if it's going to be too close or not. But what they do is they do xi plus k, where k is either 1, 2, or 3, etc. So you can get a close proximity of the random value right next to it, which is k equals 1, or 2 away, 3 away, etc. So in other words, you're plotting x1, x2, x2, x3, x3, x4, x5, 4, x5 if k equals 1. And that's what this plot is. And that's what I'm going to do. So this is sort of set up for this already. And so what I'm going to do here is, and so the problem with the graphics program is it doesn't let you specify the x-axis, only the y-axis. So you have to do a little bit of jiggering here, but it's not too hard. So let me show you how to do this. So basically, the A column just grabs the previous B column. So if I echo this, I'm going to say echo. I'm going to echo cell A2 from A to A3 to A100. And that's just going to right now do 0, but then I'm going to echo. I'm going to echo B1 over range B2 to B100, and so that's the formula. And now it's actually going to compute that for seed equals 1. And yeah, so you get all these values. But the example in this thing has seed being 79. So I'm going to rerun this by saying execute. And I'm going to change seed to 79. And so now I've printed 100 plottable value pairs. And they are, yeah. And they're going to repeat eventually, every 20. But so in order to plot this, what I need to do is sort it on one or the other so that I can get a, because again, I can only get y values, not x values. So the way to do this is I'm going to sort this, and I'm going to sort this on the B column. So I'll just go F3 order B 1 to 100, and that's going to sort that. And again, I'm going to now save that. F3 file. I'm going to export it, and I'm going to go and say data, and I'm going to go A1 to B100 by column, and I'm going to call it MDV1, my first rand, and do that. And so what I've done is I'm going to be plotting basically the A column is going to be my plot to show you what this looks like with regard to, and you'll see it's going to kind of, it's interesting. But let me go to, all right, I'm in Easel, and I actually have it in 64, so you can default it in 80. Which gives you a little wider, but which I did for Abacus because it made more sense. But here, I think it'll just squish it more, so I'm going to leave it in 64. So I'm going to import the one we just saved, MDV1 rand 1, and microdrive's working. That's nice. And it's going to look like a mess initially, but we can manipulate how we want it to view. We have two plots, and what we first want to do is edit, get rid of the key, and then we want to pick one. We're going to pick column A. So F3 view. By the way, we're going to say column A with format. If you do this, this kind of shows you all the things that the different kind of plots you can use in Easel. We're doing sort of the third one, which is a line plot, but without the lines. You can also do a bar graph. But we're going to do, actually we're doing, I think we're doing 0. Right, we're doing 0, but we're going to change that. So, yep. But what we can do here is we can go and say, okay, let's F3 change lines to 11. Yep. And so now we're getting sort of, and again, we can also go, to make it a little easier, we can go F3, change graph paper to, again, if you do question mark, it's 5, is the empty one. You can select it. So this is going to look a little better. And so here, what we're kind of getting is we're sort of getting this plot, but sort of in a 3D, because all of the pluses are sort of the depth of these. which is, and again, if we plot the other one, so if we go old data call B, yeah, you'll see that it's sort of in steps. And again, we can change lines to 11, which gives us just the line. You can kind of see it's in steps from, so it's not as discreetly covering 0 to 100. So let me go back and try to create a different graph. Okay, I'm back. I reloaded the fresh one because I wanted to do a different plot this time, and here's what I'm going to do this time. On this one, instead of just printing it out without doing anything, I'm going to amend, and here I'm going to add if B1 is equal to my seed, which is at index 1, 1, then just print done, otherwise print B1. Okay, and so now I'm just going to echo that to A2 to A100. And that's going to do, it's still 0 because there's nothing on the B side, but as soon as I fill in this, so this is just going to be echoed, echo B1, B2, oops, to B100. And so now it's going to echo it, but with seed 1, but the magic seed number that it has a repeat where it actually impacts this plot is 79. So I'll just have to execute it and give it 79. And you'll see we will, yep. So now it has, and if I go to let's go to 18, you'll see that at A20 it stops because, let me do the split window. Reasonable, it needs to be down. Oops, right there. F3 window, horizontal is separate, and then if I go, you see that my seed is 79 and it's repeated. So then I can just go F3, rub out A21 to B100. And I'm going to then put a 0 here. And I'm going to echo that. From A21, so A21 to A120. So if I go to A120, yep, you see it has a 0 in there now. So if I go back to, sorry, I want to go to A21. Then here what I'm going to do is I'm going to put in a 1, and then this is going to become B21 plus 1, and then that I can echo B23 to B100. Nope. I want to echo F3, echo B22 to B23 to B120. And if I go to, again, just to check, to go to A120, then indeed I have the last ones here. So now what I can do is I can sort F3 order on B from 1 to 120, and that is going to give me Yeah. So that's sorted, and then it's going to be, that's, yeah. And so that's going to give me the values on this side of all the plots. So X, Y. And so let's, if we export that, we're going to go File, Export, and this is going to be data, range A1 to B120 by column, MDV1, call it RAN2. Again. Saved. And so now let me go back to the business graphics program and show you what that plot looks like. Okay, back in Easel. Now let's do the one we just did. We're going to File, Import, MDV1 RAN2. And this one is going to hopefully look more like this graph here. And basically what this is showing is out of 100 dots, this has clumps because it repeats. So you'd expect it to have 100 dots. This only has 20 dots in here. And again, now you can see the red line shows you that it's a nice even transition. And we're going to do this rather quickly. We're going to say edit key F4, that gets rid of the key. And we're going to say no graph paper. You can see through the bar graph that you can already see the shapes, but let's do it F3, change graph paper to 5, and we're going to just plot column 8. So again, you can see the red line just says it's a nice smooth transition from 0 to 100 because that's the one that we filled in with 1 to 100. But if I go old data, column A, it's only going to print those. And then from there on, I can say change to lines to 11. And that's going to give me this, which is actually this plot. And it's this plot, except I believe it's like this. So those 3 dots are those 3 up there. It's just that it's stretched. And you can kind of see the pattern. You have these 3 are those 3, and then these 2 are those 2, right? So yeah, so that's the plot. So I was able to create this plot using, with a little bit of, creativity. So now let me show you what the actual good random number generator is that uses the 16807 and the 2 billion basically. 2 to the 31 minus 1. It's called the Park Miller. All right, back one more time, back with the same one. This time we're going to change things up. We are going to put 7 to the 5th. We're going to put 0. And we're going to put 2 to the 31 minus 1. Okay, so that has a tremendous impact. This time what we're going to do is we're going to just plot them all the way up to 255. And so we're going to go ahead and do that. So just F3 echo A2. Again, the max you can do is 255. And again, F3 echo B1, B2 to B255. And what we're going to do is we're actually going to repeat this again. We're going to string this together so that B255, we're going to grab, we can change the units, F3 units, enter integer minus sign, and yeah, the whole thing, it'll just change into and then here what we can do is just like here we're taking B1, B2. Here I'm actually going to take B255, and that's going to grab the last one in that column. It has to recalculate everything, so it's a little slow, but that's okay. And then this one is going to grab, well, this one then we can do the normal stuff. And so what we want to do is we're going to go F3, F3 echo. We're going to echo A2, and we're going to echo it C2 to C255. I'll have to change the units again. I'm surprised that it didn't hold, but that's okay. And we have to do one more. Yeah, and then we're going to go F3 echo B1 to D1 D255. And that should echo the entire. So now we have 512 random sequences, two sets of them, because we took the last value. We took the last value in the B column as the first value in the C column. So that's how we strung that together, and it's going to be. Yep. And here it goes. And again, we're going to just go F3 units, enter integer minus sign, the whole range. There we go. And if we go and just do the bottom part, and F3 window horizontal separate, and go to F4 A255, you can see that the 4459, then just like 312 becomes the first one in A, 4459 becomes the first one in C, and then it keep alternating. So we have two values. Okay, so what we want to do is we're going to sort first F3 order by column B, 1 to 255, and that'll give us, yep, takes a sec, but just a lot of values to order, and there we go. So now we're going to export F3 file, export data range A1 to B255, and by column, and this is we're going to call this MVV1 ran3, and then we're going to sort by column D and do it one more time. We'll have two. And again, here we don't need to fill. You'll see when we plot the sorted row that we get the diagonal linear. So because these numbers are so vast and we kind of have a decent coverage, we don't have to fill them in with 1 to 100 to get to normalize. And you'll see that once it's exported. So I'll do the same for the D column, and then I'll import both of those into the graphics program. So you don't have to wait once this is saved. Hopefully it'll save. Again, I'll do the same for the sort by the D column, and then save rows C and D. But I won't let you sit through this. So let's go to the graphics program. Okay, for the final set, let's see if I can't change. I'm gonna change the graph paper to 5 right away, so I don't have to deal with that. I don't know if it'll remember to. Anyway, so this time we have 2 that we want to load in. So we're gonna file, import from MDV1 RAND 3, and memory might be dicey. We'll see how much memory I have to do that. The files aren't very big though, but it is going to be a rather big file, so we'll see how it goes. And it's a bigger file, so this is reading a bit more. Yep, definitely a bigger file. The numbers are also bigger, that's why. And hopefully that's all it has. Oh no, it's still doing it. It's a good cartridge, so I think it'll be fine, but come on. It shouldn't run out of memory. There it is. And it's going to be a little bit messy because there's lots of data. So again, look at the red line. You can see that we're getting that nice sort of growing plot, which suggests that the data is sort of normalized between 0 and the end of the graph. So that we don't need to, yeah, and again, I'm going to, let's just do, we want to do old data 8. And so that is going to get rid of, yep. So now we can kind of see what this looks like. And if I change the lines, so F3, change lines to, and what I can do is I can actually redefine. I'm going to define a new one. So I'm going to go and set that to line color should be black, symbols on, symbol color should be green, line thickness should be 0, satisfied, yeah. So that gives me now a graph that looks like that. And there you can see that it's starting to look like a scatter plot. And then what I'm going to do is I'm going to load in the other one as well, and then I'm going to show you the end product. So again, I have two 255 ones, and again, I'm trying to give you this picture here that's in color. So let me load in the other one, and I will just I'll just swipe to the finished product. How's that? Here's my scatter plot. I showed the color version of this earlier. So I hope you liked this video and show you a little bit of the power of the QL in terms of what it could do with regard to the software it had, and it can still even use it to this day to do this kind of stuff, albeit a bit slow. But I'll end here. Thanks for joining me, and I'll see you next time.